My name's Nick Krippner. I've been with DeZURIK for 10 years now, regional sales manager on the municipal side of the business. Here today we're going to talk about all things pump control. When we talk about pump control, you need to be able to have controlled opening, you need to be able to have controlled closing, and then you also need to be able to get shut in case of a power failure event. So once you have those things accomplished, you need to have the right capabilities to accomplish those, which is in some cases, traditionally, you're looking at some sort of stored energy source, whether you're talking about hydraulic, low pressure water hydraulic, high pressure oil hydraulics. Here's a different type of technology where we're using an electric motor powered actuator and then coupling that with a mechanical style check valve to accomplish all three of those things. This is a lot more maintenance free kind of approach in regards to accomplishing all those same things. A lot of you may think of what do you do in a situation, you've got the electric motor and the check valve and power failure event, would this not fail in last position? Well, that's exactly correct. But when you couple the torque unit with the traditional mechanical style check valve, the way the yoke is designed, what you end up with is the ability to swing shut just like a mechanical check valve on a power failure event. So first thing, you need to have the logic. That's either done by a local control panel, we have the offer to provide that as well, or by SCADA, or some system that the municipality already has in their thing. We can integrate with that. So that's step one to it, and that needs to communicate to two things. It needs to communicate to the pump itself and to the pump control valve. And then that logic will speak to each other and perform that functionality. On a normal standard startup, the logic is going to say, hey, valve, you're closed. You're gonna remain closed. We're gonna turn the pump on. What that's going to do is you're going to deadhead the pump, you're going to build pressure. Because in order to move water the proper direction that you're trying to do it, you need to have positive pressure. So when you have your static head, say it's 50 PSI, for example. You've got 50 PSI of static head, you start your pump control logic sequence, we want to do a controlled opening situation. When we do controlled opening, the logic will say pump turn on. We're going to build pressure until we receive 50 PSI or higher. And then that is also going to communicate via pressure switch. There's a pressure switch that will trip that will allow saying, hey, we're over 50 PSI. Valve, you can begin to start opening, and we're going to start moving water the right direction. And then once it gets to fully open, it'll remain fully open until the logic says, hey, we want to have a standard shutdown. In a standard shutdown scenario, the first piece of the logic will be, hey, valve, start going shut, pump, stay on. We want to keep moving water. We don't want backflow to go through the valve. We want to do a controlled slow closure while we're pumping. And then once we hit a limit switch at around approximately 95% shut, that'll trip and say, hey, pump, you can now turn off. And then we'll get shut and there'll be no fluid reversal and it'll be controlled opening and controlled closing. And that's the main functionality of why pump control valves are utilized, is you want to mitigate or even fully eliminate surge pressures. The definition of surge is a rapid change in fluid velocity. So if you extend that time over, you therefore mitigate the surge because you're not creating a rapid change in fluid velocity. Again, just to recap here, this is our CPC SmartCHECK valve. This is a pump control valve that does not have to utilize stored energy. It's more maintenance free. So the ability to have full pump control capabilities, then you have the availability to utilize electric motor operator and have a pump control valve at the same time.